Thank you all for attending this lovely fireside chat together with Bob van Luijt, CEO at Weaviate, vector database industry leader. Tell me, Bob, vector embeddings are a thing since 2019, 2018, I believe.
Well, the vector embedding itself is like really old. It's like so because it's just it's a conceptual way of capturing information in a space, in a vector space, and we can go as deep as you want into that. But it came back into prominence when deep learning came back. So the when I started, it was 2015. So there was Gla from Stanford, and so the problem that you basically try to solve with vector embeddings, for those who don't know, is that the one of the things that we tried to do in solving language with machine learning models was that the question was asked like, so how can we capture the meaning of the words in the sentence? And there's a very old, I think it's already 200 years old or something, this concept where you say a word in a sentence says something about about another word on how closely you are in the sentence. So the easiest way to think about it is an example. So if you take two words like Eiffel Tower, then probably you're going to find the word Paris somewhere in the sentence more closely than I don't know, Amsterdam, right? So that's how these models were built, and you can just build a matrix on that, right? So you take we call it co-occurrence. So you take every word in a dictionary. So think, for example, the Wikipedia page. You take all the individual words, and you make a matrix, and then you basically say, okay, how close is Amsterdam related to that word? Yeah. How close is Paris related to that? And you take
semantic search, that is.
Yeah. Well, no. It was not semantic search. It was just it was literally a matrix for co-occurrence, just to say like how close are they related to each other. The problem, however, was that, as you can imagine, if you just imagine it as like a big Excel file, right? If you do it with a Wikipedia page, you're going to be fine. But if you're going to do it with the whole of Wikipedia, it just gets linearly slower. So it doesn't work. So what they started to do is that they started to compress that in an embedding and then train the model to predict what the embedding would be. And that was wildly successful. And that was the first step in the usage of embeddings. And back then there was single word embedding. So there was not related to sentences yet or those kind of things. It was not the transformer architecture yet. It was just the prediction of how these words would co-occur in a sentence.
Which year was this we're talking about?
2015.
2015, yeah. How did you end up with the idea of starting Weaviate? How did you know you were going to be bullish on this technology?
Yeah, so we have to fast forward a little bit in time. So 5 years later, I was working actually as a software engineer on an IoT project. Where we got data in from different vendors. So think, for example, elevators, those kind of things. They had APIs and descriptions of the APIs. But the problem was there were so many APIs coming in that we couldn't correlate the data. And back then I was a big fan of the semantic web. And I got to this insight that I think that the semantic web is never going to work. Sorry for the semantic web fans. And the reason I think it's not going to work is because as humans, we don't agree on how to call stuff. Right? So in my example, one manufacturer of an elevator might describe something completely different than another manufacturer because they have a lot of knowledge about it. I just go like, isn't that just a door? And they go, no, it's a very special door.
Everybody has their own realities of
exactly.
Words. Yeah.
So the idea came up like, what if we use these word embeddings and vector space to determine what's similar? So you take a description of an API, you take the individual words, go into vector space, find the center point of all these individual words, and that's how we're going to define that data object in vector space. And that actually worked pretty well. And then we were like, hey, that's nice. Where are we going to store this stuff? Nowhere. So then we had this idea, and here my co-founder plays a tremendously important role, HN. We're like, well, there's a famous search engine, a library that every database, not everybody, but a lot of databases use, which is Lucene. So it sits at the core of Solr, of Elastic, of MongoDB, of Neo4j, of Cassandra. If you do search there, just keep going. Yeah. And then we figured out that the way that you build that index to search through vector embeddings scales differently than Lucene does. And that's why we started a new database.
That was 2019, 2020, just before ChatGPT became a big thing.
Yes, because it's very important. So 2 days ago, there was a Weaviate meetup in New York. Hundreds of people show up. Well, I can tell you the first Weaviate meetup in New York, I organized that meetup, and 0 people showed up. So back then I was just traveling in the back of the plane, Berlin, Amsterdam, New York, San Francisco, organizing these meetups for my database, and people rarely showed up. So then I had to eat the pizza myself, drink the beers, take a picture of the Brooklyn Bridge with the eaten pizza. It's like, oh, the first meetup was a great success. But that's how we did it.
Okay,
but now a lot of people show up, which is actually nice.
Yeah. And of course, ChatGPT helped with that, I think. The popularity of vector databases grew. I remember working on trying out the OpenAI API, working with my own data and trying to make a chatbot that was trained on my data. And I started with these tutorials on YouTube about vector embeddings. And Weaviate was one of the first tutorials I ever saw. Did you notice that you could ride the wave with the effect that ChatGPT had when it was launched?
Yeah, certainly. So the reason that ChatGPT was important, because we were already collaborating with OpenAI for the embeddings. So they had us like on their website, it's like, this is what you can use to work with these embeddings. But if you build a infrastructure company or software company, then one thing that you're looking for is something unique. So the problem was that we had before with the embeddings that we could only position ourselves as better search and better recommendation systems. And you don't want to build a better system, you want to build a new system. And what ChatGPT did for us was that, so we already had that collaboration with these companies and these model integrations. We already even had modules that we call generative search. They already were there, but ChatGPT wasn't released yet. And what happened was ChatGPT got released, and a lot of businesses said like, hey, how do we do that with our own data? And then we were like, hello, it's right there. You can start right now. And that was the first time that a unique case emerged, where with Weaviate we were like, look, we're built for this. This is what we do. We already even have it. You can just 5 lines of code and you're good to go. And that was just right time, right place. So we got lucky there.
Wow. So what I'm seeing now in my own social media feed is that we're also progressing towards a ecosystem where AI is run locally. I've seen something called the Web LLM project, where you can basically run a lightweight version of Llama 3.2 in your browser without any internet. And when I try to integrate and create local embeddings, I found myself in a place where I thought it was very hard to find information on how to proceed with building embeddings locally. Do you have any advice on AI engineers on how to proceed with creating local embeddings? What are the best models out there? I've seen things like BERT.
There's actually an interesting relation to the previous panel and about Holland and that kind of stuff. So I'm very bullish on CPU inference because there's a lot of software innovation happening there, a lot of compression happening there. So we will see a tipping point sooner than later, where you're going to go like, hey, just a handful of Intel CPUs. It's just same output as just loading the whole thing on a single GPU. And that's going to make it cheaper to run these kind of things, and it makes it easier to run it locally. So recently, and now of course now I'm blanking on the name of the project, but somebody points me into a direction of a project, purely CPU inference, nicely parallelized over different CPUs. So the more CPUs you have, the faster the thing runs. Nicely done, works great, based on sentence embeddings. Comes out of Holland, right? Isn't that great? And I'm blanking on the name of the project, but it's my point is a lot of stuff is happening there. Nomic, that startup, has done a lot with CPU inference. So that's not for the LLMs yet, but it's for the embedding models. So that's just around the corner. And there will be an innovation soon as well. I would be expecting like in token prediction, and because at some point you're going to have just trade-off. Like, okay, I can buy X, high quality Intel CPUs or rent them or buy them. That actually is cheaper than a single GPU, and in a proper parallel process, I just get stuff faster. So why wouldn't I do that?
Yeah.
Scale's easier. When you want to scale GPU, you always run the risk that you run out of GPU. So, I mean, and VIA is going to be fine because we need these things to train models to make them. But we're on the inference side of things, right? And that is a different ballgame.
Yeah. So this topic, the main topic of this talk, is also keeping up with the everlasting changes in the AI space. Things are moving so fast. The things I explained during workshops last year are already outdated, horribly outdated. How does a company like Weaviate keep up with these changes? How do you keep your engineers, your researchers on track with the latest in AI?
Yeah, so that's a good question. So, funnily enough, keeping on track with it is not so much the challenge, because we have people on the payroll to do that. That's their job.
Yeah.
What is more difficult is that sometimes you're ahead of the curve a little bit. So I have a researcher on the team, Connor is his name, and Connor published this Weaviate blog about a concept called generative feedback loops. He explains in depth how it works with Weaviate. So you generate something after a RAG pipeline, and then you feed it back into the database. It's a generative feedback loop. Nowadays, we call generative feedback loops agents. So what is way more important, if you feel that you're a little bit ahead of the curve with something, that you keep your eyes open for the nomenclature that the community will adopt. So that you don't stick with your own language, and then the community goes, what the heck is a generative feedback loop? And you're like, well, it's an agent. It's like, why don't you call it an agent?
Yeah.
Right? So that is something that is way more important, that you ask yourself, is there something here? How is it called? How do we position it? And that's what I say. So next month is going to be the Weaviate, the database agents are going to be released, which I'm extremely excited about because it's really baked into the database.
Yeah.
And that is something we've been working on for quite some time, because we knew through these generative feedback loops that was coming. But you just need to make sure that you use the right language. Because the longer your product exists in the market, the further you get detached from renaming it, or like not detached, but the possibility to rename it and those kind of things. So, long story short, staying ahead of it is not that hard, especially if that's your focus. It's more making sure that you position it well, that developers understand what you're doing.
Right. Let's talk about agents. What, according to you, is the definition of an agent? I see so many examples on the internet, research papers, claiming to say, this is the definition of an agent. It does this, it works autonomously, it works in a loop, it keeps on going until it achieves a certain goal. But most examples I see on the internet, of quite a lot of examples, are like, hey, I have built a stock tracker agent that fetches the information from the NYSE stock exchange about a certain stock. I'd think, all right, I could just call an API, Yahoo Finance, and ask what the stock price is of a certain company. So what does an agent actually do, according to you, that builds on top of existing features and API calls? Yeah,
so I'll answer the question, but that example you gave is actually pretty interesting, because I don't think that what I always like to do is, if there's a formal academic definition, we'll take that one and then we water it down. I haven't seen one yet, so I need to, how I look at it, so this is my definition, that's probably going to change in the coming months, but basically it's an LLM that has access to a system, right? And you can make that feedback loop happening. What's also happening, and in the beginning, when I started my company, I was annoyed by it, but later I actually understood that it's a positive thing. If people are going to start to call, in this specific case, something an agent, where you're like, that's not really an agent, right? I could just call an API. That's fine. That just means that the language is catching on, that people are excited. Mm-hmm. You just need to make sure that you don't step into the trap as a developer, as a company, that you step on the bullshit train, right?
Yeah,
So you need to make sure that you keep it real and that kind of stuff.
Yeah.
But the fact that people take some liberty in how they call things, also agents. I mean, we started this niche called the vector databases. Nobody cared about it, and now all of a sudden everybody.
No, yeah.
When I was like, I saw a talk by the founder of Oracle, Larry Ellison, and Larry Ellison, he's like, I don't know how old he is, but he's like 900 now, and he was like, Oracle is also a vector database. I was like, really? And I was like, that's actually kind of cool if Larry Ellison says that. So it's it's fine.
It's nice. Oh, interesting. What do you feel about? Do you perceive threats from other companies in your immediate surroundings? As an example, Google released their new Flash model 2.0. I think it has a context window of about 1 million tokens. I played around it the other day, and I was able to stuff the contents of 3 books inside of it. 3 books I got from the Gutenberg project, where you can find all sorts of books. I just stuffed the book contents into a prompt. I hid a very small sentence. Patrick van Everdingen is an AI engineer. And I prompted Flash 2.0, can you find a sentence about me, Patrick van Everdingen? And it found it. In quite a sense, this is a rack solution, yeah. Does that frighten you sometimes? That
no, so it's interesting because I get this question a lot. And I look at it completely the other way around. And the example, and the reason is very simple. So what's a database, right? So if you think about back in the days, you had cards with phone numbers.
Yeah.
So the little cards with the phone numbers is a database. Then you also had, back in the days, you had a database management system that was called a Rolodex. So you put them in and then you had to go like, Patrick, and you went to the P and then you found your number, right? So that's what a database management system does, right? So Weaviate is database management system. If you look at a large context window, and for those who really want to nerd out on this, if you use the transformers library from Hugging Face, you can actually just go in there and see how it works. So what happens if you put in your 3 books in the context window, a word is translated into a token, the token is translated into a vector embedding, and so you have like a huge array of vector embeddings. That's your context window.
Yeah.
Well, the whole thing of a database management system is that it's good at creating new stuff in it, reading stuff from it, updating stuff in it, and deleting stuff in it in a consistent way, that you can trust that the system does what you ask it to do. So I hear vector embedding all the time. So the bigger the context window becomes, you need to have a database management system that manages that to keep state. And who's very good at keeping state based on vector embeddings? Well, we do. We're good at that. Mm-hmm. So we're doing a lot of work with the team of making the distance between the context window and the vector database smaller. So now you have these steps in between. So word, token, embedding, generating something, back to the vector database. And we said, like, why don't we directly do that step in the database as well, so that the vector database becomes the context window. Yeah. So that's how we look at it. So I understand the question. Yeah, I get the question a lot, but I see it completely different because it's embeddings all the way down.
Precisely. Wow. So, if I recall correctly, Weaviate is written in Go, the language. What was the choice to? Why did you decide to proceed with Go instead of another language?
That's an excellent question.
I don't know any Go. I just know TypeScript, which.
Yeah. So it depends a little bit on how deep you go into this question. At some point, I can't go deep enough, but and then you should ask my co-founder. But one of the things is, of course, you need to pick a language to build a reliable system in. So you saw Go was used a lot. I believe like CockroachDB and those kind of databases also written in Go. There was back then. A little bit later, you saw a lot of Rust. You need a language that you can compile, right? So that you can build high quality scalable systems. So you can do that with Go, you can do it with Rust, C++, Java. And Go was just a language back then to pick, and we're still very happy with it. We but if you look now, we fast forward a couple of years. So if you look at, for example, the retrieval algorithm that just basically checks like all these embeddings, that's all the way optimized in assembly. So there's like actually assembly code that sits in the database. So it's more that you need a language that gets you somewhere quickly, but allows you to go into the depth for all these optimizations. So it's easier to give an example, but in our opinion, would not be a good decision to build a database with. And then you talk about Python, JavaScript, so those are interpreted languages. So that's more, and then you gravitate to one or the other, and we gravitate towards Go.
Would you have done it differently with a different tech stack when you would have to start over again with Weaviate? Would you have chosen a different language if you would have? You're looking back now over the past years.
Well, I don't. So that is really something we should ask the engineers. But I think the more I notice that the more senior the engineers become, of course they have a couple of pet peeves, right, here and there with certain language, but they go like, yeah, whatever, right? It's like
as long as it works.
Yes,
right?
exactly. Yeah. So I don't. But again, this is something really that we should ask the engineers that work on really the hardcore database stuff today, because I don't do that anymore. Yeah. I think what I find also interesting talking about languages, that's on the other side of the database. So one thing that we've did early on that I'm very happy that we did is that, so Python is the most used language to interact with the database right now. And Weaviate started off as with a client where you really have like the nomenclature in the client is like you're now going to talk to an external system, right? So it was through the APIs. We completely rewrote that for all programming languages. So we started with Python, but then TypeScript. We're now doing it with Java, where we're making it more look like a library. So that you feel as if you're interacting with a library in your language of choice rather than a client. So you might have like one line of code, but in the background it might do 4 gRPC calls to Weaviate. And so we're starting to abstract that away, and it's more turning from a client into a library from how you interact with it. And that is something that I find very interesting as well, that development.
That happened, wow. On the data side of things, I hear a lot of my colleagues who are not very bullish on AI and agentic coding. They are saying like, oh, the internet becomes so full of AI slop nowadays, articles written by AI, images created by AI. That internet theory is a thing, according to them. How do you think that AI has sort of plateaued right now because of the lack of additional good training data that we feed the LLMs? Or do you think there is a path for synthetic data?
Yeah, so that's a difficult question to answer, because what people sometimes forget was when we saw the first version of the LLMs, they were like, they were like, meh. And they were good, but sorry, the LLM. So you have Microsoft's, the model is called Gödel. So you can play around with it. It's still on Hugging Face, I think, and it's like, meh, right? And a lot of people thought, looking at the data, that we were hitting a plateau in what you could achieve with transformers. Yeah. And it was only a small group of researchers that thought like, no, actually we just want to keep going. We're going to throw more data. And actually it turned out that it didn't plateau, but it was an S-curve in the development. So long story short, we don't know with synthetic data if we are reaching another plateau or that we're reaching another S-curve. I'm a little bit bearish on it, because the tokens generated in synthetic data are, of course, from the knowledge that's captured in the model.
Derived from
the model. So, but who knows? We shall see.
Yeah, we shall see. Let's talk about multimodality of data and information. You mentioned using embeddings for textual data. When you started Weaviate, did you already take into account that we could also create embeddings for things like video, images, audio, etc.? Was that already a thing back then?
So not multimodal. So yes, we were thinking about it because we started to see the first image models. I I got completely obsessed by the capabilities of multimodal possibilities, because I think it started at Facebook, again at Facebook. Funnily enough, related to what we just said, so there's another AI company in the Valley, contextual AI, and the guy who started that is a Dutch guy, Douwe, and he's like a multimodal guru. He's very smart about like how you shape these embeddings and that kind of stuff.
Mm-hmm.
And it was a conversation that I had with him that for the first time that there was something that I didn't knew, is that if the models have more world understanding based on different modalities, the output in a single modality actually becomes better as well.
Okay.
So
that was an unexpected result.
Yes.
Yeah.
So that was like so we're now with the LLMs, we're saying we're running out of data. But so this is an example how this S-curve might emerge. We can make LLMs better by just training them as multimodal models. So we take the bucket of textual data we have, and now we're going to add imagery to it. I believe that paper from Facebook had, and I'm saying this from the top of my head, so I might be wrong, text, audio, images, heat maps. They had a couple more modalities, but they tried to mimic the human senses in that model. Audio, of course. Audio. So so maybe that actually, makes us take off again.
Precisely. Do you think other types of data are a candidate for vector embeddings? Maybe DNA is a language, of course. We have a certain amount of bases in our DNA that act as a language. Do you think that we'll store information like this in vector databases eventually? Or do you see a moral limit to this kind of things?
No, not yet. So it's like if you also look at the experts, I think, and somebody that comes to mind is Jean LeCun. So one of the things that he talks about is that he's saying like the way that the transformer architectures work is suboptimal, because if we want to really mimic human learning, we just need to look at a child, and we don't need a child to read every document that's on the web yeah. So but it was interesting what I saw in a talk of his where he makes some predictions and has some ideas about how this might evolve. The vector embedding plays a tremendously prominent role in that. And the same is with, I know startups that build models for DNA and that kind of stuff. Mm-hmm. And again, they represent the DNA string in a large vector embedding. So most likely for the foreseeable future, if the way that AI develops right now, the vector embedding is not going anywhere.
All right, all right. We have time for a last topic, I think. Could you spill the beans on the vector database agents feature for Weaviate that you're releasing? What does it do?
Yeah, so we're going to have 3 agents. They're all going to be released in March. And the first one is called the query agent. The second one is a transformation agent, and the third one is the personalization agent, which is re-ranker. So what the query agent does is that you can ask it a question about your data set, and it just literally goes through your data. It understands what's in the tables. It knows how to make a semantic query. It knows how to set filters to retrieve that information for you.
Does it translate the user query at first into a more suitable query?
Yes, so the result you get back as a developer is not only the answer, but also the queries that it wrote to get to that answer.
All right, yeah.
And the transformation agent allows you to add data to your database. So if you now have you can have a query agent, you can keep that as context, give it to a transformation agent. So a simple example might be, so we have like a data set of a factory, and we say like, and that factory has ovens, and we say every temperature in this data set needs to be in Celsius. Then it just goes through it, and if it finds something in Fahrenheit, it says like, hey, actually, it's in Fahrenheit, it should be in Celsius, creates a new data object, storing it in Celsius. Okay. But what's even cooler is that if you combine it with the query agent, and you say, okay, check all these ovens, and how they're running. So it checks all the ovens. It's like, hey, this oven is off, because it's like triple the temperature. You might want to check out what's happening there.
Something's off.
Exactly.
Yeah.
And you can prompt it however you want. And that is something I'm extremely excited about. And so we have like models running, tiny ones, who are the database agents. And it's completely intertwined again with the client. So you can just give your prompting, your system prompts just in the client. And now what we're so used to, you create a collection in a database, you query it, you can now just give it an instruction, like a prompt. And it just does it in the background for you.
Wow. Amazing, amazing. Our time is up. Thank you so much, Bob, for these insights on the vector database.
Thanks for having me.
Space. And can I get a warm applause for Bob? Thank you.
Thank you, everybody.
Thank you.